imagine that we have, again, a particle that is forced to live in a box. The box, it's a cube of the sides that all have length L, and it's in a superposition of, so psi of x, y, z, say at t equals 0, is an equal superposition of the ground state psi 1 and the first excited state psi 2. So it's something like that, where these are the eigenfunctions of the Hamiltonian. So let's consider psi x, y, z, and t. Right, so each one of these functions, we're going to need to integrate over x, y, and z of psi n x, y, z modulus squared dx, dy, dz. This has to equal to 1. And we know what this looks like. It's just individual psi x, psi y, psi z that we're familiar with, one-dimensional versions of an object that is constrained to live between 0 and L in those respective dimensions and those respective directions in x, y, and z. So this means that, well, so psi of x, y, and z as a function of time looks like what? So we actually have a choice here. So first of all, 1 over square root of 2, and then we have, so we know that the ground state has sine, it's pi x over L, the same for y, sine of pi y over L, and the same for z, pi z over L. And each one of these has a square root of 2 over L, so overall we have 2 over L to the 3 halves there. That makes up an eigenfunction that we call psi 1. And then we have the time-dependent part, which is e to the minus 3i, h squared t over 8m L squared, and that forces an h bar. But that's h and 2 pi here. We could simplify a little bit, but either way, what we really care about worrying about is the second term, because it's we have a choice. Okay, we still have the 2 over L to the 3 halves, right? We know from the one-dimensional system, the particle constrained between 0 and L, that all of the functions, even the higher energies, have the same 2 over L square root. So that's going to carry over here. But now we have sine of, we could say pi x over L, sine pi y over L, and then change this one to 2 pi z over L, and then increase the energy. This becomes 6i h squared t, so this is e to the minus I et over h bar, so this is 8m L squared, and there's the h bar. We won't simplify that further, but there are also other choices here. So there are 2 other choices that we could construct. They have a 2 here, and a 1 here, and a 1 here, or a 2 here, a 1 here, and a 1 there, and they would have the same energies. So, you know, what is the frequency of oscillation of the probability density? Right, so when we do psi of x, y, z, t modulus squared, right, we get the probability density. this oscillates at a frequency which is the difference between these two. So we have a frequency there of, or an angular frequency, 6h squared over 8ml squared h bar minus 3h squared over 8ml squared h bar, which is 3h squared over 8ml squared h bar, or let's finally simplify this to 3 pi h over 4 m l squared.